Hello, my name is Dylan Jackson, candidate number 1755. This is my computer science NEA testing video for my technical solution. First test here, the player can click on any legal tile on the board and one of their pieces will be placed on that tile. Do that, click on here, pieces appeared, that is a pass. Next, the player can click on any illegal tile. Standard would be any legal tile on the board. We're not placing. Extreme is one that is very nearly a legal move, so any of these that also doesn't work, and erroneous would be off the side of the board, and none of those are doing anything, therefore that is a pass. Player can place a tile to outflank an opponent piece horizontally. That's been done here, but we can do it again with white. That is a pass. Next, the turn will alternate after the player has moved. Yep, there it is. The player can place a tile outflank a opponent piece vertically. I've just shown that, and but we'll do it again here. White. I think we'll just start a new board actually, so I can keep on top of this. It's a nice fresh board. Go vertically. That is a pass. The player piece can place a piece to outflank an opponent piece diagonally. You can place a piece here as white that will outflank this middle piece here, like that. That is a pass. Next, the player can outflank multiple pieces in one line. So for this one, I'm going to. There's not any immediate ones. But now it's now white's turn. White can outflank these two pieces in a line. This should both flip over. So it's a line of white, which it does. Pass. Very nice. The player can outflank multiple lines in one move. So for that we could do, it's black's turn. And we could, is there any in this situation? No, I don't think there is. So we will do white instead. If white places here, this will outflank here horizontally and vertically, which it does. That's two lines in one move, that's pass. If no moves are available, it becomes the opponent's turn. That I will load a file for so I can demonstrate. There we are. You can see it's black's turn, however it can't move. If I click on this, what should happen is it should switch over to white's turn, which it does. That's a pass. Next, the game ends if neither player can legally move or if the board is full. Well, to check if the board, if that works, if the board is full, we can play white here because that's a legal move, and that will fill the board up. What this should do is cause the end menu screen to display. There it does. And black had one, so that is a pass. Next, can't move. I will load another board for this one. This board looks like, I pull it up, it's here. You can see that it is all white apart from this one little gap here, and it is black's turn. Therefore, black can't play anywhere on here, neither can white. So what will happen is when I load this file, the game will just automatically move to the end screen as it realizes that neither player can move. There we are, it's the end screen, that is a pass. Next, a draw is announced if the game ends and both players have the same number of pieces. can load a scenario. Here we are. If white was to place here, it would outflank these two black pieces, therefore resulting in the board being half black and half white with the equal number of both pieces. Therefore, a draw should be returned, which it is. Okay, next, these are some tests to do with the AI functionality, some black box tests and one small white box test to check that the AI is functioning normally, or as expected. So, first test, when a single player is selected, the AI will place a piece on its turn. When I place this piece here, it should be the AI's turn. The AI will place. That is a pass. The AI can outflank player pieces. It just did. We'll do it again. There it goes. Can go in all the same directions as the player. This next test is for the AI will assign a value to each possible board state. This is a white box test. If we have a look, we'll start up a one-player game. If we click on this piece, the AI will move, and we'll be able to see in the terminal that it has gone through. So currently it is the minimax should be running on a depth of 4, I believe. No, sorry, that is here. Yep, depth of 4. So that's why there is so much text. This is a total value for every single state that is analysed, and at the end it comes up with a best value for the current state, which is -3. So that is a pass. Next, we do some tests for the menu and the file functions. First of all, when the game is opened, the main menu will display. So when the game opens, the main menu is displayed. That's a pass. Next, the buttons can be clicked. The buttons can indeed all be clicked. That's a different test for later. That is a pass. The start button activates when a difficulty is selected. So you see it here, you can't click on it. If you click any of the other buttons, nothing happens. However, if you click on one of these difficulties, it activates and you can play the game. That is a pass. Next, the difficulty and number of player buttons can be clicked to determine the type of game. Already shown, but I can do it again. Click on a normal game, you can see down here, it's selected normal. And if we go for one player game, we'll select minimax. Two player game says 2 player. And so on. So that is a pass. Next test is a white box test. The game board loads the appropriate board from the board templates folder. So what this means is that in here, the board is, when the game starts, the board is pulled from one of these 3 files, depending on the game mode. If we click on hard game, we should expect to see a board with white counters in each of the corners. If we click on easy, black counters in each of the corners, and normal is just the standard. So we'll try easy first, black in each of the corners. So that is a pass, because the correct board layout has been output. Next, the easy button can be clicked to load the easy board. There we are, that's the pass there. Next, clicking the hard mode will load the hard board. You click on hard, the hard board has been loaded with the white in the corners, so that is another pass. the load game button can be clicked to load a game from a text file. I've already shown that, but I will show it again for the test. If you do select a game mode and you click that, click load, you can then enter a file name. For example, we already used some other, so I will use bwin.txt because you haven't used it yet. That's like this. So that is a pass. Next, the user can enter a file name. So for load game, what should happen is if the file name contains a character that is illegal for a file name, it should be rejected, and instead it should just load the default game board, being the normal board on two-player difficulty, two-player game mode. So we can try that. Well, first of all, standard test, which is just my new file.txt. My new file.txt. This should be fine. And what this should load is this here. So there we are. That has been loaded correctly. First one is a pass. Next, the erroneous is this string of illegal characters. If you do that, what should happen is it should just load the default board, which it has. And of course the extreme, which is just an empty. There's just without entering anything. This one should be okay though, as there is a file that exists. So blank.txt does exist. So this should be alright. We'll do a better test for this because this one is not clearly distinguishable at the moment. So I'm just going to do that so you can tell that it is actually working. And we'll just save that. And now if we run it again and do the test again, enter blank, just .text. The file has been loaded. There we are. So that is a pass. Next, we will try the same things, but with JSON files this time, because the game also supports loading from JSON and saving to JSON files. First one is example.json. Example.json. That has loaded this, which is what I believe to be example.json. Yes, it is. So that is a pass. Next, the erroneous is a string of illegal characters, but with JSON this time. There we are. It has been rejected. Has been rejected, and the normal board has been loaded. The normal board has been loaded. That's a pass. Then the extreme is a blank.json. So just .json, which loads that, which I believe to be correct. Yes. So that is a pass. Next, the user can enter a name of a file which doesn't exist. Do that. I just enter a load of random maybe try not to enter any erroneous characters. Do that. That file does not exist. Therefore, it should just load the standard normal board, which has done. So that is a pass. Next, the user can click on the instructions button to read how to play Othello. That is back in the menu. Click on the instructions button. There is the how to play page. So that is a pass. The game can be quit. There are 3 ways to do this, either by pressing the closing the window, pressing escape, or pressing the quit game button. First of all, we'll close the window. That works. Next, quit game. That works as well. And finally, escape. That works as well. So that is a pass. Now we move on to file saving. So clicking the save game file button, save game button will let the user enter a file name and save the game in its current state. That is specifically the text file. So if we just play a bit of a random game here, and then we want to save to a text file, click that button, enter whatever, my lovely file, and enter. Saved as my lovely file.txt. So that is a pass. Next, it can be saved to a JSON file. Same thing. Do that. My lovely file.json. So that is a pass as well. Now, user can abandon the game with the abandon game button. Click on abandon game. That will take you back to the main menu, which is a pass. Okay, next we'll move on to some of the white box tests. This first one is looking at get flanks, which is here. This one is the function responsible for getting once the input is given and the tile is selected, it then takes that, works through it, uses these different directions, applies these directions to it, so until it comes across a piece of the opponent's colour. Once it does that, it carries on the same direction. If it then comes across a piece of its own colour, the opponent pieces are then considered to be ready to be outflanked. And the list of possible ones, which holds the ones it's come across, is then added to confirmed chords. So we should see that here. Click on that and see starting get flanks. Tile being assessed is 5-3. So that's this tile, the one we've clicked on. Current direction is that, it goes to 6-3. There's nothing there, so it turns around. It doesn't turn around, it goes to the next direction. Does all that until it finds an opponent piece. Then it carries on, finds one of your own pieces, a turn piece. Therefore, these flanks are definite, as in 4-3. So it returns 4-3 and then displays to the board. That is a pass. Next, we are going to look at, first of all, I'm going to put some comments onto here so these don't get in the way. We're going to look at gen moves, which is the function responsible for generating all legal moves that the player can choose. So if we go up here, we'll just take some of these off. The way this one works is that it systematically goes through every tile in the board and inputs the coordinates of that tile into get flanks. If get flanks ever returns something other than an empty list, then it means that it can get flanks and therefore it is a valid move. So I'll show you that. I can show that here. It's a normal game. Click on that. Does it a lot, obviously. It does it once for every single tile in the board. It goes through all of them, every single tile. And eventually it finds one. Oh, there it is. Yep. So it's found. Here are the flanks received after that round, 3, 4. It was the tile that was inputted was yeah, it was 2, 4. This 0, 1, 2, 0, 1, 2, 3, 4. This one was inputted, and it found this piece, which is a flank, therefore can be flanked because it's got one of the own pieces on the other side. Therefore, this piece was assigned. This tile was confirmed as a valid move. It then does that for all of the others until you have a list of all confirmed valid moves. So that is a pass for that one. So what we're going to do for this next one is we're going to test the minimax function by testing that it can do recursion to the correct depths. Over here in use minimax, we can assign the depth here. First of all, we'll start it as 1, and I've got some print statements in place so that I should be able to see the recursion happening. There we are. Only depth of 1, so it can only check the moves that are available on the board. That is good. That is exactly what we expected to see. Next, we're going to use depth of 2. This should just increase it slightly because it now has another board another board state that it can take from. So there we are. It is longer. You can see this is current depth 1 and current depth 0, rather than just depth 0. So I'm going to change to 3. So increase again. There you go. You can see that it is now it's doing a depth of 3. It can access an awful lot more moves. And finally put it back to what it usually is on, which is a depth of 4. You can see there's a lot more recursion taking place. Minimax starts here, it's done all of these. It's checked every single one of these coordinates, so that is a pass, as it is doing recursion to those depths. Next, for this one, going to want to test the value calculation in Evaluate. Way we're going to do that is by just uncovering, pop a comment on those, and then in Evaluate to get rid of all these comments so that these will be used. What Evaluate does is it uses the heuristics, so it uses corner weighting as well as mobility heuristics, which is like how many moves the AI has compared to the player. it also has adjacents, which is the adjacents to the corner. So it will want to be in a corner because that is an advantageous spot, whereas around the corner may put the opponent in an advantageous spot. So it wants to avoid those as much as possible. And move value is just the difference between, is just the number of, it's based on the number of pieces of both colors. And yeah, so what we can do, we'll test that. You can see it is very clearly for each of these getting a mobility heuristic and a corner and a move and adjacent value. It's not the most useful at the moment. However, if I change this, well, not the most obvious what it's doing, if I change this back to 1 and then quickly run through a game, quickly run through a minimax game, preferably. What we should now see is that it will want to start moving towards this corner. As you can see there, I can't outflank that piece, therefore that is an ideal spot for it. If we then, for example, move here, if I then go here in order to outflank this, it will immediately go straight for, oh, it can't go for the corner, but it will still want the corner, so it will set up ready for the corner here, so that next turn it can take this corner because this has the greatest value of the pieces of the tiles on the board. So if I just get out of its way and go here instead, it should now take the corner. There we are, it took the corner because the heuristic, because of the corner value being higher, and it therefore wanting to maximize its ability to get the corner. So that was the last test. Thank you very much for watching.